Hello, everyone. Welcome to the binary episode of the podcast for this week. I'm Spectre. With me is Z. We'll cover the Spot the Vuln challenge, as always, and then we'll get into our topics. So, Z, take that away.
Yes, this week's Spot the Vuln is based off of some CTF things I've seen, although not actually not in a CTF challenge, but in CTF platforms. This one's just a race condition. Specifically line 15, it kind of runs the query where it's just updating points equals points plus whatever value it's supposed to have. Nothing's necessarily wrong with that line itself, but on a whole, this is kind of set up in a way more or less using like the Flask API app.route. You could see this elsewhere too, of course. As long as you can make multiple requests, you can potentially get multiple things into that or to pass that challenge.check flag check, which in theory should just be looking at, is the flag that was submitted correct? And have multiple threads enter there, then have multiple threads trying to increment the points. Depending on how racy the actual database is, some of those may work or land and some won't, but you've got a race condition here. You can get unlimited points in a sense, or many more points at least than what you should actually have gained. Race condition, one of my favorite issues to see on the web. Anytime you've got something that somebody's expecting will only run once, such as in this case, you're only going to have points added once, is a place where you can just try and spam requests at and try and get this sort of issue to rear its head.
Can't believe you said just a race condition, as if it's not the one true bug class.
Well, that's fighting words.
Them be fighting words, yeah. But yeah, I mean, we covered an issue like this a long time ago in a undisclosed CTF platform. Like specifically this exact issue where you could submit a flag multiple times to get multiple points. So
yeah, and it's something I have seen like when I used to play more CTF. So I've seen this one multiple times. Actually, the one we both did challenges for before 0x. I did this against them also. I mean, it's just one of those things, like, as usual with race conditions, if you're not thinking about the multi-threaded aspect, it's super easy to have it rear its head.
I didn't remember that issue existing in that previous platform. You never told me about this. I feel
I got
betrayed.
myself a bunch of points there.
Oh, wow. Okay. Yeah, I wasn't even aware of that. But yeah, like you said, just one of those things that's easy to like skip thinking about, the concurrency on the web. All right, so let's get into some of our topics for this week. Up first, we have a Talos report on a Chrome WebRTC use after free. This is through the addIceCandidate function, which is used to add interactive connection establishment candidates when establishing a WebRTC session. The problem there is, as an attacker, you can set up a promise to execute for setting up the local description, and that promise will mark part of the local description memory to be collected by the garbage collector, but that marked memory is then accessed again in addIceCandidate. So if you can trigger garbage collection by applying memory pressure in between the local description setup promise and the addIceCandidate function's execution, you can trigger use after free. As you can guess, because this is a browser and use after free is a very powerful memory corruption primitive, they state it's possible to take this to code execution, though as always with Talos, they don't really go into the exploitation details here, where it's a browser especially. They just kind of end off the post with a sand dump of the bug being triggered. But yeah, I mean, it's another one of those cases where there's a promise or a callback that can be invoked that can do something dangerous, and then, the code here for establishing an interactive connection establishment just doesn't account for that.
Yeah, I guess one of the things that is at least a little bit interesting here is the fact that often when we end up talking about these with promises, it kind of has more to do with extending the lifetime beyond what's expected. In this case, I mean, the promise is the one I believe that's marking it as freeable.
It's shortening the lifetime, yeah.
Yeah, so it's a little bit different, a little bit unique from what we've covered before, I think. I mean, it's still the same basic issue and all that, but yeah, I thought that at least stood out a little bit.
Yeah. So they don't have a POC here. That said, this is one of those issues where it's simpler to the point where I think it would be somewhat easy to reconstruct a POC. Given the stack trace and given their explanation of the bug, it doesn't sound like it's too hard to trigger. It probably only takes like a few lines of JavaScript. So, um, yeah. Unlike some of the other Talos reports that we've seen and actually dropped from the podcast because um, where they don't provide a POC and where it's a complex issue, it's really hard to figure out what's actually going on because these reports are intended for the vendor, right? Um, they don't want these to be easily weaponized by like script kiddies or whatever, so that's why they exclude the POC often. But yeah, this is one of those ones where I think you could probably reconstruct it somewhat easily. But yeah, I mean, like I said, whenever you have something like a use after free in the browser, it's almost guaranteed to be exploitable eventually. It's just too powerful of a primitive to have in such a complex
Yeah, well,
piece of software.
do you know how often in the browser you really run into like isolated heaps or anything of that sort, which would just make the
Yeah.
use after free a bit more challenging?
So there has been work in browsers to, like you say, isolate heaps to try to mitigate heap corruption. So, for example, like certain types of objects, like JavaScript objects, they'll usually end up in like a JS core heap, whereas like an HTML object, like a text area or something like that, is going to end up in the DOM heap. So as an attacker, you kind of have to bridge that gap and move your heap corruption one heap to another. There also has been, I think, other things added to like GigaCage and stuff, though I'm not too familiar with that stuff because a lot of the browser exploitation I did was on kind of older builds. I didn't really have to deal with some of those newer mitigations. But yeah, you're right. There has been a lot of work to try to mitigate heap exploitation in the browser. That said, just because of how many different options you have and the different, like there's thousands of different like HTML objects and JavaScript objects, right? So it's not generally in my experience it hasn't been too difficult to find an object that can help you cross that gap. Um,
Yeah, I mean
but
they're
yeah.
complex applications, so unless it's basically isolated to you've only got this object in there, you're going to have kind of that bridging room.
Yeah, I mean, it's like you said, it's partially because it's so complex, but the other thing is too, it's so entangled, right? Like
Yeah.
HTML and JavaScript is so closely woven together that it's basically impossible to isolate one from the other. So yeah, I think there's always going to be a way to bridge that gap, but I don't know. Maybe I'll be proven wrong. Maybe there will they are definitely working on trying to mitigate more and more on that side. So it does get harder, by the year, but.
Yeah, and I mean even if they were to say do more isolating there, like even like I said, if you had a heap that's only one, there are still kind of attack vectors, getting like freeing things back, like freeing the actual memory page that's on back out and things like that to get it reused elsewhere. There's hopes regardless, I guess I'd say, for exploitation even with that sort of mitigation in place.
Yeah, you can kind of use tricks against the operating system there. Yeah.
Yeah.
So speaking of operating systems, up next we have a Linux kernel use after free, which was introduced in kernel version 2.6.36, but is also introduced in v4.13 because it's in two different socket options. But nonetheless, like even if you just go to 4.13, that's been around for quite a while. The issue is in the SO peer cred socket option, as well as the SO peer groups introduced in 4.13. Those socket options don't use any locking or maintain any ownership when copying the SK peer cred object into user space from the socket buffer. And you can race those with other areas that use SK peer cred, such as Unix Stream Connect and Unix Listen. And I believe those areas will actually free it, and that will lead to a race use after free. Jan Horn from Project Zero says this impact is limited to a use after free read and thus information disclosure, because you can get like some other object to overlap with the SK pure cred when that gets copied to user space. So could be is a useful information disclosure there. There is a theoretical path where this could lead to out of bounds write to user space memory on SO peer groups, but he notes due to privileges, an attacker wouldn't easily be able to switch out the pure cred on that socket. So, and even then, you would be getting it in user space memory, so it wouldn't really be super useful anyway, if I'm reading it correctly. But yeah, I mean,
Yeah,
information disclosure is still a really powerful bug. So
he kind of hedges the potential one as like, you know, maybe, but
not really worth
um
investigating.
yeah.
Yeah. But yeah, like information disclosure is still really powerful, especially where it's in the kernel core like this. This could be very useful to chain with a different bug. Um, Final thing I'd like to note here, since we do like to talk about methodology when possible, the bug here was found through manual source review, and they note that in their report, like metadata. So yeah, just wanted to point that out because we do like to talk about like whether or not this bug could have been found through fuzzing or source review. Um, I think this could have been found through fuzzing for sure, although it's kind of difficult because when you get into race conditions, those are just um, there's so much luck involved and so many other circumstances involved that it's somewhat difficult to fuzz for unless you're specifically trying to target that. So yeah, it makes sense that this was found through source review. That's kind of what I would expect. But
Yeah, I mean,
yeah,
to catch this one through fuzzing, I guess, I mean, it is used after free, so like KSAN could have picked it
KSAN
off,
should detect
maybe.
it.
Yeah.
Yeah. Because that's the other thing too with fuzzing, right? Is you're limited on your detection mechanism. So here, like we're saying, it would have been fairly easy to catch because the use after free is just something that KSAN is really good at catching. If it was something more subtle though, like it led to a bug further down the line that you would need to craft an exploit to do anything useful with it, then yeah, it wouldn't have caught it. So that's another thing to keep in mind. But
Yeah,
yeah, totally makes sense that was found through source review though.
I'm actually a little bit questioning now. I think when I first read through this, I, took some high level details, but where is the free happening? Because I mean, this talks about, so it can race with anything that updates the SK pure cred. So that being the connect and listen. Is this effectively if you close it? Or, no, I'm kind of just missing where the actual free is happening.
So you can kind of get that from the KSAN report, although it's
Uh,
actually not that useful because, um, okay, actually, yeah, it is because they have the last potential related work creation. So basically, when you use the listen sys call, it initializes this task that gets executed later on that will um, free this object. I'm guessing because when they do listening, they allocate a new one, so it's just free the old one, use the new one.
oh yeah,
So I'm
that would
guessing
make
that's what's going
sense.
on there. Yeah.
Yeah,
Um,
I just kind of recognized I didn't have any note on that, and we're talking about it as a use after free. Kind of important to understand where the actual free happens or when it
yeah.
happens.
Something else, since I just I was looking at the KSN report here. This does seem like it's maybe not as good as it initially seems because like it says the buggy address belongs to this object, which belongs to the cred jar cache. So you're not getting this use after free in a generic cache like a kmalloc cache. This is only happening in the cred jar. So there's definitely like an info leak potential there, but I do wonder how useful it would be because um you're kind of limited to whatever's getting allocated in that cache. Like if it's only one object that's getting allocated there, then this would be really tricky to take advantage of. That said, I'm not familiar enough with that cache to make any judgments on that. But it is something I wanted to call out where I was just looking at the KSN dump where we were looking for where it's freed. So um, but yeah, I mean, still, it's a race, and we love races, but the impact there, I'm a little bit maybe wasn't as high as I initially thought.
Yeah,
All
I
right,
mean, as long as you're, it depends on what's in there, but as long as you're getting a pointer in there somewhere, that's still going to be useful on the info leak side.
for sure. Yeah. So next up, we have a manu post on GitHub Security Lab on exploiting 3 bugs in Qualcomm's Neural Processing Unit, or NPU, driver on Samsung phones. Notably Samsung, because this driver is privileged off in most other devices from unprivileged users, because Project Zero actually pointed that out in a previous report. But for whatever reason, on Samsung devices, the NPU driver could still be reached from untrusted users. Um, so the NPU driver, as you can expect with neural processing being involved, it's a fairly complex code base. And so it has a bunch of ioctls for doing things related to neural networks. So, like mapping and unmapping DMA buffers, loading the neural network models and unloading them, executing them. There's a
Yeah,
bunch of
I
different
was going to
steps involved
say
to using them.
that I don't feel like mapping DMA memory is exactly a neuro. Uh, oh, what's the last half of that word? For some reason, it just slipped my mind. But you just said, but
Oh, neural
yeah,
processing?
yeah, neuroprocessing. Oh, I get what you mean, but just the way you bridge that one from doing neural processing related stuff like mapping memory.
Yeah, so
But
the
yeah,
mapping
using
memory
it
is
for
fairly
the
benign.
models. Yeah, you
But
explained it
yeah,
right away, right after. But
Yeah, the main thing I was trying to get at there is you have to take multiple steps to do stuff with neural networks, right? Um, so there's 3 bugs here. The first bug is heavily based on the fact that most of these commands are synchronous, but some of them are asynchronous, like the exec network command. And that can be done by setting the async flag in the ioctl. Um, and when this like network model that you want to set up is getting mapped and loaded with the previous 2 ioctls in the setup, it allocates a network object in this global static array to keep a record of um, any information that's necessary for that network object. And that's needed for a few reasons. One of which is it's possible for multiple users or to have different users of a network. And they need to be able to distinguish between the different users so that they can only access their own network, right? Trying to keep it isolated. And they also want to identify the user that makes calls in an asynchronous fashion, right? Because they need to be able to keep track of that. So as such, that network object contains a reference to the NPU client object associated with it. Now, obviously, later on, when that file descriptor is closed, those references have to be cleared because this is a global object. It's not an object that's local to the file descriptor. So you can't have dangling references to clients that have been freed. So this function, NPU host cleanup networks, is called in the close path to remove client references and clean up those network objects. And that function will finally do that by calling free network, which I believe like zeroes out the object and whatnot. The problem is there are some error paths that can end up short circuiting that free network call, such as by running another command on that network. If you do, it'll return ebusy, and those references are still left there. So by just sending an async NPU exec network command and quickly closing the file descriptor, when the NPU later finishes that task and tries to send a message back to the CPU, it gets processed by this at message proc function, which will use the client object that was just cleaned up by the close call, right? So there's where the use after free happens. There's the use after free on the client. The second bug was a much more subtle bug where when they process K events or kernel events, they go to copy this reserved, the contents of this reserved zero field to user space with copy to user. And that reserved zero field is where they store the stats buff object, which gets set up earlier. So basically, like the user passes the stats buff object that gets copied into this kernel controlled buffer. And then later on, they go to copy the contents of that buffer back to user space after, whatever is done on it. But instead, they, because of a 1 character issue, they end up using the address of operator on that field instead of just passing it directly. So instead of copying out the stats buff contents, it copies out the stats buff pointer and thus leaks that pointer. Furthermore, the size of stats buff can be larger than the size of a kernel event, so that can lead to the out of bounds read when that copy to user call happens. Ultimately, what that allows you to do is leak a kernel heap address of contents you control. since, like I said earlier, stats buff is filled with user-controlled memory. And that's very useful for, if you need to fake an object, and modern devices are going to be using privileged access never, you need to fake an object in kernel space, and obviously if you're going to pass a pointer to that object, you need to know where it is. So that leak is very useful for that part of the chain. The final bug was due to unions being used because, of course.
I just want to step back there and just call out or reiterate on that point. That was just that one character use of address of,
Yeah.
which, I mean, they were intending that as just being the K event object, I'd assume. Oh, it's one of those things that, one, I feel like this should have been picked up had somebody, done some testing and looked at the response. Like, it feels weird to me that slipped through. Like, was there no QA on this?
Yeah, so the code, like looking at the code, it's not super obvious. It's a pretty subtle bug, but it should have been obvious in the behavior. You're right.
Yeah,
If you
like,
actually like ran this at runtime and looked at it, it should have screamed out to you.
or even like user bug reports or something. But yeah, like in the code here, it isn't super obvious. But when it actually ran, like seems like it would be completely wrong.
Yeah, because I mean, there's no way to use this correctly. Um, there's no, like, you don't have to go out of your way to trigger the bug. It just kind of happens. If you ever looked and went like, "Oh, my stats aren't showing anything. It's actually showing a kernel pointer." This is kind of not what
Yeah,
I
I mean, you
expected.
might not recognize it as a kernel pointer, but it's like, whatever it's being parsed as makes no sense.
Yeah, it's not what it's supposed to be. Um,
Yeah, I guess maybe that does depend on what those stats actually contain, which I did not look into.
yeah. Um, but yeah, I mean, we've seen some bugs like this before where they've accidentally used the address of operator. I mean, using pointers in C is hard, so it happens sometimes. But yeah, that was a very useful bug as part of the chain. The final bug was due to unions being used in MSM NPU events, which eventually gets copied to user space. They have a union of various objects like execute done, execute b2 done, and SSR events. I'm not sure what those are used for. I did a quick Google search, but I couldn't really come up with anything. But it's not really relevant anyway, so I didn't spend too much time in that. But basically, because the final union member there is just a 128 byte auxiliary data buffer, unions in C will expand to the size of its largest member. So the union here ends up being 128 bytes in size, which is far larger than some of the other, like the size of some of the other objects here, like the event execute v2 done, for example. So because of that, there's uninitialized data that gets copied to user space in the trailing bytes. They don't like do a mem set or anything to ensure they don't leak data here. So yeah, kernel information disclosure.
Yeah, I
So
like this bug. Like, that is just, it's one of those somewhat subtle things, because even if you were doing something like, I mean, if you mem set the whole object itself, then yeah, you're going to be fine because the size of the MPU event will be good. But if you were to be using just the size of whatever the union structure is to zero it, you would end up still leaking memory.
I
So,
mean,
oh no, it's,
I'm just gonna take another opportunity here to say, like, just don't use unions. Like,
yeah,
why?
we've said that before. Um, I mean, it's a language feature, but it's so easy to introduce bugs here. You do kind of violate, dry principles if you make multiple structures of different types. You do
Yeah,
kind of reduce the whole, like, you'll have multiple objects with very similar names in theory or something like that, um, for these different potentialities, but I don't know. I mean, I could understand from a developer side why union is used, but from a security side, I I guess it's kind of like unsafe in Rust. It tells you to look for issues.
yeah. As soon as you see a union, you should be like tunneling in on that because, like you said, they're just hard to use correctly. So yeah. All three of these bugs get chained together for an exploit. The second bug with the address of issue is used to get the address of the stats buff and reclaim it with their own data. which, as I said, is useful for faking a kernel object, which they need to do later on. The third union bug was used to defeat KSLR and get a kernel function address for a gadget. And the first bug, the UAF, they used to get code exec, and that was done by abusing a function pointer that gets executed from the client wait queue struct in the useAfterFreed client. So by using the second bug to get a controlled object with the function pointer to whatever you want to execute, which you find with the third bug, use the UAF to get hijack of the control flow there. He then goes into detail on post-exploitation stuff like disabling SE Linux via setting enforcing to 0 and popping a reverse shell. Here there was also a bit of an oddity because basically what he does is he smashes the permissive mode variable to run SE Linux in permissive mode. That variable is supposed to be protected by kernel data protection, which is enforced by a hypervisor, so it's like a privilege level higher than the kernel. I believe that's done through Nox. But that wasn't actually being protected by kernel data protection. It was just like forgotten about or something. So he was literally just straight up able to disable SC Linux by just smashing the kernel variable.
I mean,
Very weird.
that sounds, like Nox. We've talked about some Nox issues before. It's like Samsung's trying to be more secure, but then they have...
But not trying very hard.
and then they have these...
They have some other security subsystems too.
Yeah, I guess what I'd say is like they have these kind of immature seeming bugs. I can't think of the right way to describe it. It just feels like some of the bugs they have they're trying to do some of the right things. Like their idea, I don't think is wrong to be more secure and implement some of these security features, like positive move, but then it's almost like, maybe the dev team, I don't want to call it the dev team as being like bad devs or something, but just the types of bugs being introduced by it. Ultimately, it kind of makes me question, using Nox, because, for everything it fixes, it breaks.
It's just a naive implementation, it feels like. It feels like a lot of
that could be
like good decisions were made, but then when it came to the execution phase, it's just was kind of like thrown together. I don't know. Because like you said, we've covered like 2 or 3 other things with Nox before where it's like this should have been prevented and it just wasn't thought about.
In fairness, like not quite to the same, I wouldn't say this to the same degree at all, but we've seen kind of similar things with like Pack on Apple where they're taking a very strong step there in terms of security, but then the actual implementation has seen some issues there. We've talked about Pack before also, so I won't dive into that, but it feels kind of similar to that, although to a different degree.
But yeah, I mean, with this post, super cool attack chain, 3 different issues that all had to be chained together to exploit this bug, all in the same driver, and it's a powerful exploit. I mean, this is a untrusted to kernel, so on Android, that's huge. I did want to pull a question at a chat. I wanted to wait until we were finished with this topic. What do you both think about Rust? So we've talked about Rust quite a bit, actually, as recent as like last week, because we had Bash and Guru on for that. Rust is like a really strong thing for preventing like memory corruption. It's not immune to it because any libraries that could be using unsafe, or if you're using unsafe, there's still the potential for issues. But the benefit for that is your attack surface is a lot more limited, and you kind of know where to look if you're trying to hunt out and destroy memory corruption. So I mean, it's a good language. The only thing is like there is a high dev overhead because it's not super fun to write. You've got to be careful when writing it. You're going to be fighting the compiler. So it's just one of those things where you have to evaluate if it's worth all that additional effort for the security. You kind of have to look at the trade-offs.
Yeah, and adding on a little bit, you mentioned there with Rust, it kind of helps you know where to look for issues. Like we've covered actually a good, like not a ton of issues, but we've covered a number of Rust issues or language or issues found in programs written in Rust. All of them but one have involved unsafe code at some point. That might be safe code that makes assumptions that unsafe code broke, or it might be kind of going the other way, that unsafe code breaks the safe assumptions. Either way, unsafe code gets involved. There was one that we talked, I don't even know if we actually talked about it. It was one that was covered in a paper that we covered on here. That was unsafe, or sorry, it was safe code only. That said, that one isn't even possible in Rust anymore. It was in like version 0.3 of Rust. Very early on, they prevented it entirely in modern, pre 1.0. So yeah, I mean that's kind of, I think, a big plus for Rust is just in terms of the code review aspect. As a developer, I have more of a development background. I like Rust in that sense because you know where you have to look for those broken assumptions. You look at the unsafe code. I think Rust is doing a lot of great things in terms of the borrow checker. I'm a fan of Rust, but I don't like the Rust language. I like what it's doing. Like, I'm generally positive about the ground that they're breaking. But
For me, it's too
it
much of
has
a pain in the
those,
ass to write. Like, I just
exactly. It
don't
just
like writing it.
has the rough edges, but I like it. I just don't like it.
Yeah. All right, so we'll move on to our last topic of the episode, which is from Power of Community 2021. Unfortunately, we don't have the talk, but we do have slides. And this talks about pwning the Windows 10 kernel using a vulnerability that I believe was exploited in the wild. Because they do mention in the
Yes.
slides.
Yes,
Yeah,
so
okay.
it was, there's been a little bit prior right up here too. But yeah, it was found in the wild initially by Kaspersky back in June, I want to say it was.
Right, okay.
And then Alex Plusket here, I'm not sure if I'm getting the name correct, actually did a couple write-ups about this during the summer. Because we were on our summer break, we didn't cover them. Now there's the presentation. Unfortunately, like Spectre just said, this is at POC. Generally don't get talk videos out of POC, the conference.
A lot of the
Um,
time, we don't even get slides. So it was cool that we were at least able to get slides here.
I think they have slides on their website. Um,
So I think
Somebody else
they
can
do
look
it
at.
for some of them, but some other ones they don't, because I've looked for, like, there were some talks in previous years that I found interesting, and I'm like, ooh, maybe I can find the slides for this. And it's like, nope, they're not there. It's like, oh,
Fair
well, that
enough,
sucks.
yeah.
Yeah, it
Yeah,
seems
I
kind of
mean,
hit or miss, I guess.
I wonder what that's based on. I haven't actually been to it, so I don't know, but that's beside the point. Point is, with this one, we've got a heap based buffer overflow. Getting to the point with the vulnerability, heap overflow in the extended so this is an NTFS file system code. In extended attributes, let's see here if I can. One thing that I will note, this is a long presentation with plenty of details, plenty of background. So extended attributes, somewhat user controlled. They can set their own length. They can set their own value for the lengths. But the exploit maybe isn't what you would expect it to be, because it is straightforward smashing, but it's not. Actually, it kind of reminded me of a challenge you built once, Spectre. Anyway, the issue itself is basically with calculating the padding for this. So as they're iterating through the extended attributes, this is in the NTFS query extended attribute user, and then get the list of them. From there, it takes an output buffer, user controls the size of that also, and then as it's iterating through all those extended attributes, it's going to place them at a 32-bit aligned location, so they all start, at a nice position. So you control what the size of that output buffer is, and it'll calculate just a little bit of padding that it might need to add to a block. The problem being, even though it checks while it's iterating for the length of the block to ensure, or sorry, the length of the remaining space to ensure it can fit, it doesn't actually check for an underflow. And actually, I'm going to pull up the Kaspersky page here too, because they do a pretty good job of kind of summarizing and showing the code here and where the issue happens. which is here, where basically you end up having that underflow where it takes that length remaining, removes padding, checks the block size which it calculated, basically comparing, can this fit in there? That will underflow, or can underflow, leading to a overflow when it actually does the mem move into it, because you can, smash out beyond the expected size, or the actual remaining space. So I thought it's a little bit interesting how that actually came about, being this padding calculation. It reminded me, like I said, Spectre, of one of your 0x0539 challenges where it's a padding calculation issue.
Yeah, I believe that one was based on the fact that like malloc 0 would still allocate a buffer, even though you might not
True,
expect it
yeah.
to. So it was a little bit different,
It
but it was
is
kind of based on the same idea of
different, but it
abusing like a
reminded
check.
me. I mean,
Yeah,
calculating padding, it's another one of those places that you can kind of see issues arise when you're trying to track everything here.
yeah.
So going from there, it's basically, just your heap-based overflow, reasonable number of other objects they can target, and they did go for using the Windows notification framework. In the slides and in the other two posts they've done about this, they go into plenty of information about how Windows notification framework works, but they use that for arbitrary read write. It's not a new technique. Effectively, all doing some heap function way to actually get it so they're overflowing into their desired object. Again, that's going to depend on, because they're in the page pool here, because they're or it's going to depend if you're targeting something else. It's a heap exploit. It depends on what you're dealing with. It depends on where you are. So I won't dive into the feng shui aspect or coercion, heap coercion. They were overflowing into the state information that gives them a relative read and a relative write through the data size and the allocated size, as they can effectively just say, yeah, we actually have this really big data size or this really big allocated size, and then later that actual code can use those values and just do relative reads or writes well beyond the actual allocated or actual provided buffers. Turning that into the arbitrary read and arbitrary write, again, use known techniques for that. Pipe attributes, just overflowing into an adjacent pipe attribute in the page pool. F-link pointer in there. Inject the fake pipe attribute, and you've got your arbitrary read. Arbitrary write was using the what is this? The Windows notification framework. Again, name instance. Using one of the datas in there that gives you, or using the state data pointer in there to get right when you would write to the notification state. From there, again, it's using another, I believe, known about technique with previous mode as a, actually, sorry, that's the info leak. But from there, I mean, you've got arbitrary read write. It's basically game over, even in the Windows kernel, because you can go for your system token at that point and be done with it. As I just kind of mentioned on the info leak, there was the previous mode technique. They kind of cover, I think, two ways of doing that in this paper, which I won't really dive too much into. At least I thought the more interesting thing was just the chaining there of overflow into the relative into the arbitrary read write. But info leak was get another info leak. But that is, if you're interested, I believe that starts here on page 48.
I think it's 38. Was when they started talking a little bit about the info leak and stuff, but
Okay,
yeah, around that area.
I've got 48's the start of the previous mode thing, which is the eProcess error. Yeah, I think they talked about the info leak a little bit before that too, maybe.
Yeah, I think you're right. I think they mention it at like 38, and then they go into more depth later on. It is worth noting they came up with an exploit version 2 that didn't use that previously known info leak. But it's kind of difficult to appreciate because it goes deep into the Windows internals, and if you're not in that area, which neither Z or myself are, then it's going to be kind of lost on you. The other thing is too, when you get to some of these more technical slides where they're going through the internals of like the paged pool and the different primitives you can use, um, it's you only have slides, right? So you can really tell the like if you had the talk and you had the context of the speaker explaining it, it would be a lot easier to understand. Unfortunately, we don't have that, so it might be a bit of a struggle there. And that's not any fault of the slides. I mean, they are slides; they're meant to go with it, like a presentation. It's not like a write up, so by definition, there's going to be some missing details that you're not going to have, unfortunately. And especially as someone who's not into the Windows internals very much, it's kind of difficult. There's a lot of missing pieces there, but for the
Yeah, I
actual
mean, it's
vulnerability, I think the slides do a good job of demonstrating that, and they go through like some of the math of how they could trigger it and stuff.
yeah, it goes into more details. I mean, that's common when we end up talking about the exploit strategy. Either we're not familiar enough with all of the internals to really appreciate it, or it's just getting too far into the weeds for what we really want to cover, especially for our listeners who can't even see anything that we're looking at. Oh, yeah, at least you can understand. I hope at least. Maybe I didn't do a good job of explaining, but understand what the issues were and how they at least got to that arbitrary read write. Beyond that, it just becomes so specific to the Windows kernel. That said, we will also include a couple links here to the two write-ups that they did, which do have yet more information than the slides, as they talk about. The first one is on doing this used basically in the way that it was found in the wild, I believe. And then the second version is, the Spectre said, they didn't use that previously known technique and just use this one primitive to, or this one vulnerability to do the entire attack.
Yeah, part of the problem there is that Windows is very weird in how it does like heap stuff, or rather pool stuff, because they have like different pools or heaps or whatever, and different things use different pools, and overflow in one pool doesn't translate to another. You kind of have to find, like here, I think the Windows notification framework used the paged pool, but if it didn't, then they would have had to find something else. So yeah, it's just kind of really target specific to Windows and how heap exploitation works there. Um,
I mean,
so.
almost so like page versus not like that's just the same as your, I believe the same as the page versus non-page memory. So most stuff is going to land up in your page pool
Well,
stuff. I mean, obviously
yeah.
kernel's going to use some non-page memory too, but
Well, the thing is, I think Windows, as far as I know, is the only kernel that has the concept of like paged and non-paged memory. Linux, for example, there is no such thing as like paged memory. You're not going to have kernel memory that gets paged to disk. They just keep it in memory at all times, right? So that's another area where Windows is kind of weird in how it does things. Um,
fair, yeah.
so
And I mean, again, kind of as you were talking there, I had a little bit of a confusion, had to think about that. Like obviously page memory and memory pages exist on Linux also, but it's not like kernel memory isn't getting paged out.
yeah, exactly.
Huh. Yeah,
It gets confusing when you talk about like paging and specifically gets kind of weird because it's kind of used in slightly different contexts. You can talk about it being like paged out to disk, or you can just talk about the concept of paging and like
yeah.
virtual memory pages. It's kind of weird,
Yeah, and it's
but
easy for us to slip between things because we know what we're talking about. So yeah,
yeah.
that's a side discussion anyhow.
But yeah, like I said, I think the main like thing out of the slides there is like the vulnerability and just diving into some of that stuff. The primitives is interesting, but it might not be too useful to you unless you have some like background knowledge or you're willing to go out of your way to do the extra research to understand that.
Yeah,
But yeah,
it's pretty standard. Like if we were to make this more generic for people, like it's you've got the overflow in the heap, fair, common enough. You're overflowing a couple sizes to gain relative read write. Again, kind of a standard thing to which you attack a couple pointers for your arbitrary read write. Um, yeah, I mean that's kind of the generic takeaway, I guess, out of it.
yeah. All right, but yeah, that's where we're gonna end the show for this week. Thank you to everyone who tuned in. The VOD will be up on Twitch immediately or on YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. For alerts of when we're going live and to join the community, follow our Twitter and join our Discord. I'll put the Discord in chat for those of you who are here. And you will also find those below, like in the video and stuff. We'll be back next Monday at 3 p.m. Eastern, 12 p.m. Pacific for bounty stuff, and next Tuesday at 7 p.m. Eastern, 4 p.m. Pacific for binary stuff. And we'll see you all then.